So by 2025, we're expecting to have IoT devices produce up to 180 zettabyte of data. This is like more than 4 times what the internet represents today. This is huge. With that amount of data comes a little problem. How do you analyze efficiently and rapidly that data on the edge as close as possible to where it's produced with all the requirements and problems that the IoT is generating? Vasia from the SQL Edge team is here to tell us how Azure SQL Edge combined with IoT Edge will help you solve this problem. That's today on the IoT Show. Hi everyone, thanks for joining the IoT show today. I'm Olivier, your host, and today I'm joined by Vasia from the SQL Edge team, and we'll talk about data from IoT devices, lots of data, and how you will analyze the data at the edge. Vasia, thanks for joining the show today. How are you?
I'm really good. How are you, Olivier?
I'm fantastic. So before we jump into the topic, people, I'm sure, want to know who you are. What are you doing at Microsoft? Like, tell us a bit about yourself.
Sure. First of all, thank you so much for having me here on your platform. Hi, everyone. I am Sia. I work as a program manager with the Azure SQL Edge team. I'm very excited to bring to you this database product, which is optimized for IoT deployments.
Well, let's jump into it. First question for me is, why would you need to optimize a database solution for IoT specific scenarios?
That's an excellent question. But before I jump into that answer, I would actually like to take a moment to talk more about the IoT landscape and how data management is changing in this landscape. So let's dive into the presentation. So when you look at it over here, it says that by 2025, 75% of the enterprise generated data will be created and processed at the edge, which is actually up from less than 20% of where we are today. The Internet of Things, or IoT, actually refers to billions of physical devices around the world that are now connected to the internet. And all of these devices are constantly collecting and sharing data. So with the arrival of very cheap computer chips and the availability of wireless networks, it's actually possible to turn anything, let's say something as small as a button, to something as big as an airplane, into an IoT device. So connecting up all these different objects and adding sensors to them, it kind of gives a level of digital intelligence to these devices at the network periphery. And this network periphery is what we know as edge. So when we look at that amount of data that's being collected, first we have 80 billion connected IoT devices by 2025. And that actually translates to 180 zettabytes of data.
That's a lot of data. I was about to say zettabytes is, I think we were geeking out just before starting the recording. Like, how much is a zettabyte?
It's actually 10 to the power of 21 or 1,000 into 10 to the power of 21. It's something on that range.
Yeah, it's 1 million petabytes, which itself it's 1 million gigabytes.
Yes, that's the amount of data.
That's a lot of data. And actually, yeah, you were mentioning it's only generated by the IoT devices themselves by 2025, which is basically tomorrow, but only generated by these little guys, which actually, as a matter of fact, I was doing some research. The internet today is estimated at 40 zettabytes. Like the content on the internet today is estimated at only 40 zettabytes today. So we're talking what, like almost 3 to 4 times that value. That's crazy.
Yep. There's like 29% of increase in the amount of data, IoT data, that's being collected between 2018 till 2025. So we are speaking about this 180 zettabytes of data that these devices can collect. And that means there could be challenges in this IoT driven landscape. So when we look at challenges, we're going to talk about two types of challenges. First, let's look at network and infrastructure. So IoT devices are heavily dependent on network, but network on its own, when it comes to availability, it varies across the globe. Some of the common issues that you would find are there will be low bandwidth, low network availability in remote locations. Sometimes it results in high latency, and there is a lot of cost involved, which plays a very crucial role over here. So all of these cannot be addressed globally, even if 5G comes into picture. So for example, let us take a ship. This is a ship that is sailing in the middle of the Pacific, and there are huge stretches of water without internet, and the only internet that would be available is something like the satellite internet. And this satellite internet is very expensive, and it's not that reliable. The next issue that we would have is data. So when I say data, what happens is there is always a need to process this data at the origin for quick decision making. So with increasing volume, transmitting data constantly is expensive. And added to that, there is a layer of complexity when it comes to storage and security of that data. So now that we have seen what IoT landscape looks like and what are the challenges in this IoT landscape, this is where Azure SQL Edge comes into picture. So Azure SQL Edge is one step closer towards solving these challenges. It is a database that is optimized for IoT deployments. So Azure SQL Edge, this product is actually built using the same SQL engine that is present on SQL Server and other Azure SQL offerings, thereby providing the same industry-leading security and performance. Azure SQL Edge is a fully containerized solution which is compatible with most Docker container engines. This product can run not only on any 64 architecture such as any Intel or AMD devices as such, but it also runs on ARM64 devices. And to sum it up, it actually provides the same developer and tooling experiences as that of SQL. So when we look at where we can deploy these devices, so Azure SQL Edge can actually run on devices that should have at least a minimum of one core, that is actually ranging from IoT devices to edge servers, as you see on the slide over here. Further, Azure SQL Edge brings into reality of what we keep talking, that is, you develop your solution once, but you can deploy it anywhere. So when I say you develop it once and deploy it anywhere, we can conclude that Azure SQL Edge supports connected, disconnected, and hybrid scenarios.
So Vasila, let me ask you, so is actually SQL Edge available today? Is it something new and that developers can just take and put in production?
Yes, Azure SQL Edge is currently available.
Awesome. So let's look at the features our dear developers will be able to leverage in SQL Edge.
Of course. So Azure SQL Edge introduces a couple of new features in addition to what's already existing in SQL Server. So the first one that we're going to be talking about is something called as data streaming, which is like a native. So SQL Edge includes with it a native support for data streaming. I was talking to you about this example where there is a ship in the middle of the ocean. It has a lot of data that it's collecting. So how does it send that data into another server or into the cloud? How does it stream data? So what we are doing here is we are bringing the powers of the Azure Stream Analytics. That is the same engine that is going to be powering the data streaming capabilities inside Azure SQL Edge. So with data streaming, the next thing that is going to be of importance, especially for IoT Edge deployments, is time series processing. Most of the data that's being collected at the IoT Edge is time series of nature. So time series processing is another new feature that is being added to Azure SQL Edge. It comprises of capabilities that are already existing in Azure Stream Analytics, such as anomaly detection, but we have also designed specific T-SQL functions and syntax, such as date bucket, which is going to help query time series data. And then the next thing is native data movement to Azure. So if you're looking at, when you're looking at deployment scenarios and when you're looking specifically at a connected deployment scenario, all of the data that you are collecting and storing at the edge can be moved seamlessly into a cloud storage such as Azure. So what happens over here is you get to use this amazing ecosystem of Azure in storing, analyzing, and creating insights, not just at the edge, but also at the cloud. So the next thing that we will be bringing to the table is ML inferencing capabilities. So when I say ML inferencing capabilities, Azure SQL Edge can actually support ML models that are being trained in the cloud or on premises and deployed to the edge, where active inferencing can be done on the data that is being collected. So when we talk about ML capabilities, a user or a customer can design their ML models in any language they want. Could be Python, could be anything. But in the end, it needs to be converted into Onyx, which is Open Neural Network Exchange. And these Onyx modules is what's compatible with Azure SQL Edge. We will definitely have a look at how that's happening in a demo that I have scheduled for this session in a few minutes.
Right.
Finally, we will be talking about the performance and security. So we offer the same performance and security that you can find in SQL Server, and especially when it comes to security features, we support data encryption, classification, and access controls.
Nice. And all that, this is a lot. This is a lot, and I will not bombard you with questions because I know we're going to have a nice demo. But I want to bring up the fact that, and you will see that, I think, in an architecture diagram coming soon, that this SQL Edge technology and product actually fits in the context of Azure IoT Edge, which our audience is pretty familiar with. So you basically are describing to these developers that, hey, you now can get the power of a full-blown database engine on an IoT Edge device. And not just that, you can now leverage with high performance that interaction with machine learning, like real-time data streaming and so forth. So that's pretty brilliant. I had one little question about the data movement to Azure. Is it to be considered something similar to a data synchronization mechanism between the device and the cloud?
Yep, it is similar to data synchronization between the device and the cloud.
Awesome. And so in terms of performance and security, also, very good to hear performance being key. And I suppose because it's still in that context of IoT Edge that you can benefit from hardware acceleration mechanisms when you're using machine learning algorithms and so on. You double down on, querying data super fast, but also analyzing super fast at the edge.
Yep.
How does it look like, in the context of a solution? How does it integrate? And this is certainly that architecture diagram that I was mentioning before that will come next.
Yes. So we will now look at a reference architecture of a connected scenario with Azure SQL Edge. So what you have in front of you is divided into two different modes. One is on the edge and the other is on the cloud. Just to set some context over here, we have already established that millions of messages are being generated by the IoT devices. On your left, you can actually see a shopping cart, which is a retail or a smart factory or a connected vehicle out there. So all of these devices are constantly giving you data, and that data needs to be processed. So if you look at the architecture here, you will realize that the goal of Azure SQL Edge is to capture and analyze these data or analyze these messages. So Azure SQL Edge is a containerized application which runs the same SQL engine that you would see in any other Azure SQL services or even the SQL Server. This streaming engine that you see over here is something that's very familiar. This one is from the Azure Stream Analytics that I was talking to you about just a few minutes back. So this helps us with tasks such as anomaly detection, windowing, aggregation, etc. And that plays a key role in Azure SQL Edge's time series capabilities. The next thing over here is the trained ML models that are deployed to the Azure SQL Edge instance will monitor functioning of components in either a connected or a disconnected state. And for the purpose of this example, we see a connected state over here. And finally, this data synchronization part. This is what I was talking to you about with respect to native data movement. This data can be moved to Azure for long-term storage and further processing. So from storage services, which we see over here, this Cosmos DB or Azure SQL database, this data can also be sent for further machine learning training, or you could use it to create your own insights on be it Power BI or mobile apps, any kind of an API that you want to pull out of this solution that you have created. So from these storage services, business analysts can actually use Power BI to analyze this warehouse data. So in the end, if you look at this point over here, it just reiterates the fact that web, mobile, or other applications can be built on the serving layer as well. For example, you can expose APIs based on the storage data for third-party uses. So having seen what this architecture looks like, we are now going to see a real customer scenario. Fluggro. So for those of you who haven't heard of Fluggro before, it is a geo-intelligence provider that helps clients in the energy sector gain vital insights for marine projects. So to support its clients in early project phases, Fluggro sends a team of oceanographers, meteorologists to collect environmental data, and this data could be water depth, wind, waves, currents, temperature, all of that. So this data, which is collected through sensors on ships, is how it's initially how it was happening. So until recently, this data that Fluggro collected offshore was made available via a satellite link. So this is where satellite internet comes into action, and this data was then sent from the ship to the office that was based on the coast. So the data acquired over this satellite was then imported into a SQL server that was running on premises. And finally, the team would run analytics on this collected data to derive insights. So what were the challenges that they faced over here? So when you look at challenges, as you can see, they were unable to run real-time insights. So most of the analytics happened only after the ship had reached the coast. So they collect the data in the ocean, and then they have to come back to the coast in order to process the data. And then all of that data that they're collecting on the ship, which is like hundreds of GB, had to be stored. And that's very, very expensive. Therefore, the company actually set out to fix these problems by first moving the analytics to the cloud and network edge. So what Fluggro did was they migrated their on-premise SQL Server environment to Azure SQL Database in the cloud. Then the team devised a new process in which Azure IoT Edge and Azure SQL Edge would be deployed locally, that is on the ship, at the offshore project site. So owing to the Azure SQL Edge, in the end, given that all of this was happening on the ship, so data was now being collected on the ship, processed. There were ML models that were being trained on premises or on the cloud and then being pushed into this edge device. So all of this goodness in the end resulted in saving significant time for the company and costs associated with latency and bandwidth usage. So prominent...
Definitely for people who have been using or paying for a satellite connection feed, that's a big save on that side of things for sure.
Yep. And to top it off, reports initially actually took 2 weeks for them to compile, which at this point takes only 8 minutes for them. So significant improvement in terms of efficiency.
Nice. Before we jump into the demo, what are the other use cases or scenarios that your team is seeing customers being super, excited about SQL Edge arrival?
So when you look at use cases, I would like to say Azure SQL Edge can be deployed in almost any kind of an IoT deployment scenario where data collection and data analysis is needed. And that spans across a large number of verticals. As you can see over here, this is just a few to name: manufacturing, healthcare, aerospace, defense, and then automotive, especially with the fact that there is a lot of smart and autonomous vehicles that are coming into picture. Financial processes such as asset tracking, auditing, oil and gas, similar to manufacturing, where you're monitoring offshore oil rigs to predict failures, improve efficiency, lower risk. Retail, and finally, right in our houses, smart buildings and smart homes is something that we are already in.
Yeah, definitely. And that actually makes me think there's one point that we didn't, to my opinion, stress enough, but you mentioned that, but it's security and privacy. I mean, this is one of the constraints that IoT brings. Lots of data is created. Sometimes you don't want that data to go off premise. You want it to stay where it is being produced because there's privacy problems, or actually there's safety or security problems. Like healthcare is a good example. You might want to have data analyzed on site versus send it somewhere and have some piece of data going you don't know where. As a user, as an enterprise, as a government, I think there is a big need for having local analytics as well as encrypted and secure synchronization of data, which SQL and SQL Edge provide for sure.
Yes, definitely. I completely agree with you, Olivia. Security, especially in this age of data, is very, very, very important. I can't stress that enough.
So developer gets that for free when they're using, SQL Edge and with Azure SQL actually. So let's jump into the demo. It's time to see how it looks like.
So for the purpose of this demo, let us assume that we are the operators on the Contoso wind farm. So we have a dashboard which represents the turbines on the wind farm. And the central unit of each of these turbines has an Azure SQL Edge instance running on it. The Edge instance is collecting data from multiple sensors located in different components or parts of the wind turbine. And when it comes to what these sensors are measuring, it could be various aspects such as wind turbine, wind speed, wind direction, oil temperature, and whatnot, and even environmental factors. So additionally, data from each of these sensors is being streamed to the Azure SQL Edge for processing and inferencing. So Azure SQL Edge collects all of this data, and then it starts processing and inferencing to understand if the wind farm is functioning properly or not. And data from each of these instances is aggregated and uploaded to a cloud target. We are looking at a connected deployment scenario in this demo. So when I say that data is uploaded to a cloud target, what is happening is, for the purpose of this demo, our cloud target is in Azure Blob Storage. So data is being sent into the Azure Blob Storage. And this is essential for long-term retention and ML model training. Let's jump into this demo. So what do we see over here? An issue has been detected on our wind farm, and it's unit 34, and we are now going to dig deeper in our dashboard to see what is happening with that wind turbine. So it's running a query, and we see that there is a significant drop in the power generated by this wind turbine. But everything else, especially around vibration, oil temperature, it's all pretty much as expected. There's no fire, malfunction, or part failure. One thing that you can see over here is security alert. It says that no events are visible to the current user. So if you recollect, I said we are operators of this wind farm. This security alert is going to be visible only to security engineers and not to us. This is where one of the role-based access control security features of SQL Engine comes into play. Let's next look at the environmental issues. So when you look over here, the wind speed on the farm is pretty good, but the wind speed of the turbine has a lot of turbulence over here. And the same goes with wind direction. This is something that is actually called as wake adaptation in a wind turbine. Now that we know that there is some issue with this particular wind turbine, let's go ahead and see what we can do. First, we are going to go and look into the ML model that's up over there. So we are going to train this ML model to correct the wake adaptation error on this wind turbine. So we are using Azure Machine Learning Studio for this purpose. So let's launch it now. So this is a notebook. It's a Jupyter notebook that we have opened on Azure Machine Learning Studio. We are now going to systematically run step by step through this entire and execute all the queries on this notebook. Through this process in the demo, I'll explain what's happening at each step. But in the interest of time and the fact that it takes it takes about 5 to 10 minutes to download a trained machine learning model and upload it, I have run this experiment just before this session, and we will see how it goes from there. So first and foremost, we have to set up the Azure ML experiment over here, and this is what is happening in this place. The next thing we'll be doing is we will be fetching data from our data set to see if we are able to get some data. And as you can see over here, data is visible, data is available. And for the purpose of an example, we just took about 5 rows into 22 columns to see if we will be able to look at that data as just a subset. The next we will be doing is we'll take a description of the subset. So first, what we are going to do over here is open the Jupyter Notebook. I have opened it on my Azure Machine Learning Studio over here. I will walk you through different steps that we are going to be taking to retrain the machine learning model before sending it back into the wind farm. As you all know, the first and foremost step is installing all the requirements, the required packages. Once that is done, the next thing that we are going to be doing is setting up the Azure ML Experiment workspace. The next thing is we are going to actually fetch some data. So we'll be fetching data just to ensure that we are properly connected to the database. This is a step that you could even omit doing, but it's just done to see if our links are proper. Once we do that, let's run a subset of the tabular. And then the next step, what we are planning to do actually is to get a description of this subset, like what is there in this data. And the most important thing that we are going to be looking at is the count. So what we see over here is there's close to 8,000 rows of data, which is good enough for us to train a machine learning model. The point from here is all these queries are essentially going to give us an idea in terms of what's happening when that particular wind turbine is against the farm. So if you look over here, there is a sudden spike in the wind direction angle, and this is what is actually causing the issue. And we then run a graph to see what is happening with the wind direction angle with the farm and the wind direction angle with this particular turbine. And there is this spike, the same spike that we saw over here. And once there is the spike, there is a terminology called alter blades. So alter blades is essentially telling us that we need to correct the wake adaptation or change the motion in which the wind turbine blades are moving. So when we say alter blades are true, that means yes, a modification needs to be done for this particular wind turbine. We then go on with carrying out further examples to ensure that yes, alter blades should be true. There is a problem with the wind speed. And these are just graphs to help us better understand the problem or the issue that's happening on the wind turbine. So once we understand that, okay, it needs to be corrected, the first step that we do is we create an experiment. So this is an ML experiment, and what happens is we run multiple ML models on this, and then we run and monitor those models, and we run a job. So for this experiment, we'll be building a training script that can run on the remote compute target over here. So when then we use this compute for the job, and all of these steps is around running an experiment, creating and running an experiment. But for this particular demo, I have already run an experiment in the interest of time. Usually from start till downloading the ML model images, it takes about 10 minutes, not more than that. So if you see, this run has been completed, and the next thing we would be doing is downloading the trained model. So once we download the trained model, if you recollect, I said Azure SQL Edge supports Onyx format, Onyx being Open Neural Network Exchange format. So irrespective of the code that we have written it, so we have written it in Python. It converts that model into an Onyx format, and this Onyx format model is what is saved in our Azure Blob storage. So now let's go and look into our Azure Blob storage. So where we are here is in the container repository. So we went into the blob storage. We went into something called containers, and this thing over here has been created. So this is the Onyx model. So let's generate a SaaS URL for this, because we need to deploy this model into our identity twin. So let's change it. Write this as URL. So now what we're going to do is we just copied the SaaS URL for the trained Onyx model from our blob storage location. We are now going to put that in the module twin of our sensor module. So we go into the sensor module. We go into our module twin, identity twin. And then here in this place where the properties are listed, we will be pasting our SaaS URL. Once that is done, we save it. So while this is happening, what's happening here is module identity twin, as we can see, is essentially a replica of what's already there on the farm. So this particular place over here is actually going to be the module twin for this wind farm and this wind turbine in specific. We have deployed the Onyx model on this particular wind turbine, and we have saved it, and we have pushed it to the wind farm. Let's now have a look at the wind farm to see if the error has been resolved. So if you see over here, it says that the alert has been resolved. Once this alert is resolved, now all we have to do is refresh. And once it's refreshed, we see that the wind speed has again come back to normal and things are working as it's supposed to be.
If I understood everything correctly here, you basically are doing data collection on site and analytics. The wind turbine is adapting itself to the wind direction and force, and basically deals with the blades and directions and so on to produce electricity correctly. You actually, with the anomaly detection analytics running on the engine itself, we're able to detect the anomaly, and then you retrain the model in the cloud and redeploy it from the cloud to the IoT Edge device for it to then adapt correctly to the wind direction and force, right?
Yep, that's exactly what I did. And now the wind turbine.
All of that in a matter of like a few minutes, and that's pretty impressive, because even if it's a demo and people know it's Contoso, that's the way it would work in an actual production. Right, that's the way a customer would actually manage his wind farm and what's running in terms of algorithms onto this device. And you definitely highlighted as well that it's not the operator of the wind turbines who's going to do that. You're going to have a specific person that has higher privileges, because you certainly don't want the operator to go and play around with the machine learning algorithms running in there. But yeah, that's definitely pretty impressive from the comfort of your seat in front of your cloud dashboard, being able to control what's going on at the edge, but like the intelligence actually being down there.
True. So that is the end of our demo for Azure SQL Edge. And I just want to take a minute to summarize what we have discussed till now. So Azure SQL Edge simplifies edge architecture and, in short, IoT application development for customers by supplying a small footprint data engine. It has a startup footprint of less than 500 MB that runs on a choice of platforms and delivers consistency in data, tooling, and security from edge to the cloud. So this is powerful enough to run offline, but with the capability to connect seamlessly to a broader network of services. Azure SQL Edge actually includes built-in AI capabilities. It supports time series data, native data synchronization with both either SQL Server on-premises or Azure services, such as Azure SQL Database or Azure Cosmos. And to just say that with this, customers have a small but a very powerful data engine that meets the challenges of IoT, empowering businesses to use and analyze data collected at the network edge to save costs, drive innovation, improve safety, and thereby gain a competitive advantage.
Vasiliya, there was a brilliant presentation, super clear, loved it, demo as well, pretty clear and neat. Our developers will for sure be excited about the arrival of SQL Edge in production. So you did show a link that was aka.ms/IoT show/SQL Edge in one word, right?
Yes.
And so what's on that link? What should developer expect there?
So it is that link will actually give them access to white papers, other customer stories that are live, more information about Azure SQL Edge, and also the demos that were done and step-by-step tutorials and explanation on docs.microsoft.com. So it is a wealth of information on that link. I would encourage everyone to go and have a look at it.
I think it's clear enough. You know what you have to do? Well, before leaving, subscribe to the show, especially if you like this one. Don't forget to get notifications. Go to that link, learn more about SQL Edge running on IoT Edge. And well, thanks for watching the IoT show. Vasiliya, thanks for joining us today very much.